In this video, we will be covering part 1 of the Unit 8 notes. We will be looking at evidence of a chemical change, word equations, skeleton equations, and chemical equations. The evidence of a chemical change is a review for something that we've talked about earlier in the year. In order to tell if a chemical reaction has occurred, you could look for each of these pieces of evidence. So first would be a chemical change. Note that this would not be the result of just mixing colors. So for example, if you mix blue and white, you would expect to see something that's a light blue. But if you mix two solutions that are clear and you get something that is this purplish color, that would be an example of a chemical change occurring. You could have precipitate formation. That would occur if you mix two solutions and then a solid precipitates out of that solution. You could have gas production. Note that this would not occur from a phase change. So here I have these two substances mixed at room temperature. Neither of them boils at room temperature, and then we have the production of a gas. You could have a temperature change. So heat is either being absorbed or released. In this example here, you can see that heat is clearly being released. And you could also have the emission of light. So any of these things could signify that a chemical reaction is occurring. For word equations, you're going to be using each of these symbols within your chemical reactions. A plus sign can be used to separate either multiple reactants or multiple products from one another. An arrow is used to show the transition from the reactants to the products. If you have a double-sided arrow, that could show that a reaction is reversible and that it reaches equilibrium. We're not going to be using any examples with reversible reactions. You have your phases of matter, so solid, liquid, gas, and aqueous. And then if you see a symbol that is above the arrow, that could show that a catalyst is being used, which we'll talk about towards the end of our Unit 8 notes, or that the substance is being heated in order for the reaction to occur. A word equation is a chemical reaction expressed in words rather than chemical formulas. It consists of the reactants and the products separated by an arrow. So for example, let's say that I'm giving a sentence here. Aluminum metal reacts with liquid bromine to produce solid aluminum bromide. It's really just shortening this slightly by getting rid of all the words in the middle. So I have my aluminum, it's a metal, so I'm going to assume that it's solid. Our only metal that is not a solid at room temperature would be mercury. It's reacting with liquid bromine. So I have bromine in my symbol for a liquid. I have an arrow because I'm producing something, and then aluminum bromide, which is a solid. So if you were asked to write a word equation, that's all you have to do. All right, for our first checkpoint, we were given another one of those sentences, and we were trying to write out the word equation. We're starting off with solid iron metal. So I'm going to write out iron. It's an S for solid. It's reacting with gaseous oxygen, so plus oxygen, and a G for gas. And we are producing iron 3 oxide. So I have my iron 3 oxide, and that is going to be a solid. All right, next we have a skeleton equation. A skeleton equation is an equation which uses the chemical formulas rather than words to identify the reactants and the products. Skeleton equations allow you to see how many atoms of each element are within a formula, which is an advantage over word equations. So in our example here, it says that we are trying to convert the following word equation into a skeleton equation. So here we have our aluminum, bromine, and aluminum bromide. The symbol for aluminum is Al, and the solid carries through. This time we're showing it as a subscript. Now for bromine, you may remember that bromine is a diatomic element. So I have the subscript of 2 here because bromine would never like to be by itself. It's still a liquid. And then for the aluminum bromide, this is a compound which happens to be ionic, which means I need to cross charges. Now if you don't remember what we're doing here, aluminum is a +3 charge, bromine is a -1 charge, and then I'm crisscrossing those charges down so that they become subscripts. As a subscript, these numbers no longer represent charges. They're showing you how many of each atom you have within the compound. So I now have 3 bromines, 1 aluminum, and it is a solid. For our next checkpoint, we are going to be writing out a skeleton equation for this word equation that's provided. First up, we have carbon monoxide. Now this is a molecular compound, which is why we have the prefix of mono here. There's no prefix for carbon, so that's an implied 1. Monoxide means 1 oxygen, and I know it's a gas. So since this is a molecular compound, I did not have to cross any charges. I'm adding oxygen. Oxygen is another one of those diatomic elements, so that's going to have a 2 next to it. And then carbon dioxide. There's no prefix in front of the carbon again, so that's just 1. Dioxide, di means 2, so I have 2 oxygens this time. And I have my phases of matter for each of them. Next up, we have chemical equations. A chemical equation is an equation which shows the identities and the relative amounts of each substance involved in a chemical reaction. Chemical equations must show that matter is conserved during a chemical reaction by being balanced. You may remember the law of conservation of mass, which was created by Antoine Lavoisier. That stated that mass was always conserved during a chemical reaction. So if I have a certain number of atoms on the left side of my reaction, I should have the same number of atoms on the right side of my reaction. This can be done by using coefficients along with the skeleton equation that we were just using. A coefficient is a number written in front of a reactant or a product which multiplies across to the subscripts to aid in the balancing. In our example here, we have that aluminum plus bromine making aluminum bromide example that we saw before. But now we're going to try to create a balanced equation from that. Now I can see that on either side of my equation, I have 2 bromines over here and 3 bromines over here. The only way to make that number the same on both sides is to make them both a 6. I could put a 3 out in front of this bromine because 3 times 2 would be 6. And I could put a 2 out in front of this aluminum bromide to make the bromine 6 on the right. Now when I do this, I change my aluminums to 2. So now I have 2 aluminums versus the 1 I had before. So I also have to put a 2 out in front of this aluminum. So we're adding coefficients in front of each of these symbols, and now in the end, we're going to have the same number of each element on both sides of the arrow. This is balancing an equation, and we're going to be spending a lot of time on that within our next video. So that concludes part 1. In part 2, we are going to be working on balancing equations, and then we will continue on from there.